Dear students, welcome back to Miss Mariam's math classes. In today's lesson, we will discover what is a similarity, and soon after, we will have a lot to explore. If you're ready, let's see what's waiting for us. So let's see what content says. It says today we will learn what is a similar shape, what is a scale factor, similar triangles, perimeter of similar shapes, area of similar shapes, volume of similar shapes, and of course some practical questions. So first let's learn what is a similar shape. Two shapes are said to be similar if they are exactly the same shape but with a different size. So on the screen you see some shapes. You see, they have exactly the same form. Yes, some of them can be rotated, but still the same form, but size is different. Some of them is shortened, some of them is enlarged. So now it is time to learn what is a scale factor. So scaling all the lengths of original shape can create a similar shape. So it means they have been enlarged or shortened in the same proportion. For example, in the picture you see two shapes, C, B, A and D quadrilateral, and C prime, B prime, A prime, and D prime quadrilateral. Here we have the side 2, CB, and the C prime, B prime becomes what? 4. Here we have a side CD, and the C prime, D prime becomes 5. You see, each and every time the sides just enlarge 2 times. That's the case, we call it scale factor. So we say for these given to form, shaped form, quadrilaterals, we have the scale factor 2, and they have the same proportion. It is time to talk about similar triangles. In order to learn or in order to identify which triangles have the word of similarity, we have some rules. So we have some conditions that be followed or should be satisfied. So let's learn them. First, it says SSS, that stands for side, 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 or AAA. That stands for angle, angle, angle theorem. It says if all three sides or if all three angles of two triangles are the same, the triangles are not only similar, they are also congruent and they're identical. So do you remember these two terms like congruent and identical shapes from the previous video? Yes, you do. And for similar triangles, the three sides or the angles of two triangles only have to be proportional. If we take close attention to the screen, we will see that we have two triangles and the angle of those two triangles exactly the same. And the sides of those two triangles has proportion. Another condition says SAAS, that stands for side, angle, and side theorem. It says two triangles are similar if two of the sides of those triangles are proportional, and the included angle or the angle between the sides should be the same. On the screen, what do you see? You see two triangles and top vertex angle is exactly the same. And the sides that hold, top angle has proportional. So for the last rules or the condition that stands for similarity in triangles, it says we have angle, angle, side. It means AAS, or you can see angle, side, angle, or we say ASA, or just side angle and angle, or SAA. So it doesn't matter how big side you have, or the triangles will be always similar. It is time to do just some practical questions in order to get everything as clear as crystal. It says these triangles are similar. Find the angle XYZ and the length of the side Y and Z. Now you can see the angle CAB correspond to the angle X, Y, and Z. The triangles are similar, so we know that angle XYZ is equal to angle CAB, which is 35 degrees. Then, in order to find missing side, we need a scale factor. So, We can use any pair of corresponding sides. For example, let's take x, y, and CA. If we get the ratio of them, we will have 4.5 over 3. It will be 1.5, or just xz over CB, and it will be 3 over 2, which is 1.5. So we have a scale factor 1.5. Doesn't matter which corresponding side we are taking. So we are required to find the missing lengths. So since we have a scale factor 1.5 and the corresponding side, YZ to AB, we have to multiply AB, which is the known part, 2.5, by the scale factor, which is 1.5. And the answer will be 3.75. So the missing side, YZ, will be equal to 3.75 centimeter. And that's the final answer we were looking for. So it is time to talk about perimeter of similar shapes. For two similar shapes where one has sides that are twice as long as the sides of other, perimeter, height, bisector, and the median of larger shape will be 2 times of the smaller shape. So in general, we say that for an enlargement of the scale factor n, the perimeter of larger shape will be n times the perimeter, height, bisector, median of the smaller shape. So if the ratio of the sides is A to B, then the ratio of perimeters, heights, bisectors, and the medians will be exactly A to B. On the screen, you see 2 squares. So one of them is with a side of 4, another one is with a side of 2. So if we find linear scale factor, it will be 2. We just divide, or just we find the ratio of big side over to small side. It will be 2. If we are looking for the perimeter or the ratio of the perimeters of those 2 squares, it will be also 2 because of the word of A to B. Now it is time to talk about area of similar shapes. Actually, I guess the word of area kind of rings some bells. So for 2 similar shapes, where one has sides that are twice as long as the sides of other, the area of larger shape will be 4 times the area of the smaller shape. In general, we say for an enlargement of scale factor n, the area of larger shape will be n squared times the area of smaller shape. So don't forget, we are saying n squared times. So if the ratio, if we are talking about the ratio of the sides is A to B, then the ratio of the areas will be A squared to B squared. So you see, we have here the same squares, but this time we are not looking for the ratio of perimeter. Here we are looking for the ratio of areas. Since we have linear scale factor 2, then we will have scale factor of areas 4. Here we have 2 similar triangles. It says find the area of largest triangle. In order to solve this problem, we have some steps that we have to follow. First, we find linear scale factor. It is the ratio of large side of the triangle over small side of the triangle. So it will be 6 over 4, which is 1.5. So we found the linear scale factor of those 2 triangles. It is 1.5. So area scale factor will be square of linear scale factor. And in order to find larger area, so we have to multiply by n squared. Do you remember from the definition? Since the small area, area of small triangle is 12 centimeters square, in order to find, larger one, we have to multiply 12 by square of linear scale factor, which is 2.25. So, and the final answer, we will get 27 centimeters square. And that is the final answer we are looking for. It is time to talk about volume of the similar shapes. I guess you already know what I mean when I say volume. It means we have to talk about 3D shapes. So for two similar 3D shapes, when the side lengths are doubled, the volume is multiplied by the factor of 8. So in general, we say that if the sides increase by a scale factor of n, the volume increases by the scale factor of n cube. So here, if we are talking about the ratio of the sides is a to b, then the ratio of the volumes will be a cube to b cube. Since we have two prisms and the linear scale factor is 2, then scale factor of height, or the, let's say, ratio of the height will be 2. And ratio of the perimeters of the base of prisms will be also 2. Ratio of the surface area of those prisms will be 4 because of the n square. And the ratio of the volume of the prisms will be 8 because of the word of volume, or a cube. Here we have two vases and they are similar. The larger vase is 45 centimeter high and the small one is 15 centimeter high. It says the small vase has a volume of 0.7 liters. We are required to find volume of the larger vase. In order to find the volume of the larger vase, we have some steps that we have to follow. So let's start from the beginning. First, we have to find linear scale factor. In order to find the linear scale factor, we have to know the ratio of large height to small height. Here we have 45 over 15, which is 3 centimeter. Then we have to find volume scale factor. We know that volume scale factor is a cube of linear scale factor. So it will be 3 cube, which is 27. Then in order to find the larger volume, do you remember the keyword times? We have to multiply volume of the small vase by volume of scale factor, which is 27. And 0.7 multiplied by 27, it will be 18.9 liters. And that is the final answer we were looking for. Here we have a question, and it says A, B, and D lie on a circle. AC and BD intersect at X. The area of the triangle ABX is 5.41 centimeters square. It says calculate the area of the triangle CDX and give your answer 3 significant figures. In order to handle this question, I have to find any rule that satisfies similarity between those triangles. See, if I have angle A here, this also will be angle A because they are vertically opposite angles. And if I have angle B here, you see, this angle B lie on exactly the same arc that angle C stands. I will write here angle B as well because they are the same. And here, if I mention angle C, you see, this angle is exactly the same with the angle D because they both are lie on the same arc. So it will be angle C as well. Here we have the condition A, and A. It means angle, angle, angle. It is proved and it's satisfied. It's work here. So then, if I have angle, angle, and angle condition, it means I can use factor. I mean linear factor, then I can go from their area factor. I can handle this problem very smoothly. First, we have to find linear scale factor. How do we find it? So large over small. We have sides here. So large side is 9.4t and the small side is 4.4t. It will be 2.14 centimeter. Then I know that area scale factor is equal to scale factor with a square. Then it will be 2.14 square, which is 4.5769. Then, if the small area of small triangle is 5.41, in order to find larger, let me write area of larger triangle will be area of small triangle 5.41 multiplied by area scale factor, which is 4.5769. And I have to give my answer with the three significant figures, and it will be 24.8 centimeter square. And that is the final answer we were looking for. Dear students, dear ones, in order to succeed to understand and implement things that we are learning here, it is very crucial to be very attentive and to be well prepared. So, hope you enjoyed today's lesson and you took a lot of notes. So, now it is time to say goodbye and see what happens in the next video.